Hi children, good morning. Today we are talking about Class 10 Triangle, Chapter 6. Triangle, പുതിയ സംഭവമൊന്നുമല്ല. Can I say triangle is a polygon? Smallest polygon is a triangle. Look here, it's a triangle. Now quadrilateral also the quadrilateral pentagon like that. Anyway, we are talking about triangle. ഇതിൽ ഒന്ന് രണ്ട് കാര്യങ്ങൾ വളരെ ഇമ്പോർട്ടൻ്റ് ആയിട്ടുണ്ട്. Triangle congruency. Last year we studied. Exactly same. Congruency, the photocopy. But this year we are going to study similarity. Similarity of triangles. Congruency means exactly same. Two figures, two photos, exactly same. That is congruency. But similarity means, what I can say, that is size is same, no need of shape. In congruency, shape and size are same. But similarity, no need of size, shape is same. I can say all line segments are similar, but all line segments are not congruent. All circles are similar, but all circles are not congruent. Circles with radius same, radius 5 centimeter are congruent circles. Shape and size must be same. But here similarity of triangle, similarity of a polygon, that means angles are equal. Two triangles, two polygons, angles are equal and sides are proportional. But in congruency, angles are equal and sides are equal. So last year, be careful, congruency exactly same. Now similarity, there are three conditions. No, sorry, don't confuse congruency. There is no AA congruency or AAA congruency. Because big triangle or small triangle angle may be equal, doesn't matter. But sides are not proportional. Sides are not equal. You know that big triangle, small triangle angles, total angle is 180 degree, you can see. But in congruency, in similarity, this is similarity. AA similarity is there. If two angles are equal, respectively equal to two angles of other triangle, then they are similar triangle. Automatically, other triangle, two angles are equal means third angle is equal. No need of AAA similarity. AA similarity, corollary like that, that will do. AA similarity. Because third angle will be equal 180 minus sum of two angles. Then automatically sides are proportional. That is AA similarity. The next one, SAS. I will show you that. SAS similarity. Two sides and include angles are respectively. Include angles are respectively equal to include angle and sides are proportional. Two sides are proportional and include angles are equal. Then that is called similar triangles. AA is over. Then SA is over. Then SSS, that is common. Side. If three sides are proportional, then that is similar triangle. Then we can include RHS also. Hypotenuse and sides are respectively proportional to hypotenuse and sides of other triangles. Then they are similar. What I am telling, don't confuse similarity and congruency. Last year congruency we studied, SSS congruency, SAS congruency, then AAS congruency, RHS congruency. but no A congruency. But A similarity is there. A similarity, that means A similarity. Then SA similarity is there. SSS similarity is there. RHS also we can name. I think it is clear. A similarity, SSS similarity, SA similarity. Are you following or not? You can include RHS also. Now in similar triangle, if two triangles are similar, we know some relation altitude and median. Altitude is the line segment from vertex to the perpendicular to the opposite side. There we can see meeting place is there. Orthocenter altitude, orthocenter is there. Then median from vertex to the middle point of the opposite side, that is median. 3 medians we can draw, 3 altitudes we can draw. That median intersect, there is a name for that, is centroid. That means 2:1. It divides the median 2:1, very important here. Anyway, median, altitude, I will give you a notice that I will show that. Then angle bisectors, meeting place intersection, angle bisector, the meeting place of side from the perpendicular, that what I can say, side bisectors, meeting places. Now here I want to tell you 2 things more. It is not there in your textbook. If 2 triangles are equiangular, that means similar. Can I say? Equiangular means equiangular. All angles are equal, similarity. Then the ratio of their corresponding sides are equal to the ratios corresponding altitude. Please write that. If triangles are similar, ratio of the corresponding sides is equal to the ratio of their corresponding altitudes. Altitude, I told you what is altitude. Again, if 2 triangles are similar, then the ratio of their corresponding sides is equal to the ratio of their corresponding medians. Median 1 by median 2. That is ratio, then the ratio of their corresponding sides is equal to the ratio of corresponding median. First, if 2 triangles are similar, ratio of the corresponding sides is equal to the corresponding altitude, ratio of corresponding altitude. Now that is sides, ratio of the corresponding sides is equal to ratio of the corresponding medians. Got it? Please write it. Again, if 2 triangles are equiangular, that means similar, then the ratio of the corresponding side is equal to the ratio of the corresponding angle bisector segment. I told you what is angle bisector. Ratio of the angle bisector segment. Then, I think you got it. Altitude ratio, medians ratio, the ratio of the corresponding angle bisector segments. Got it? If 2 triangles are similar, these all are we need for the problem. Problem we can do directly, we can do for 1 more push. Then the ratio, one more thing, last but not the least, the ratio of the perimeter of 2 similar triangles is the same as the ratio of their corresponding side. What is it? The ratio of the perimeter of 2 similar triangles is the same as the ratio of the corresponding side. Ratio of the corresponding sides equal to ratio of the perimeter of 2 similar triangles. Perimeter, you know, A1 plus A2, A1 plus A plus B plus C. That is perimeter. Sum of the sides. Okay, fine. What I am telling here, similarity of triangle, don't confuse congruency. There is no A congruency, but A similarity is here. Similar means Congruence. Start with congruence. Exactly same. Exactly same. Congruency. I am not talking angle, triangle. Exactly same. Another triangle. Shape and size must be same. Angle must be equal and sides must be equal, but similar. Angles are equal. That means sides are proportional. Shape and size are same for congruency, but for similarity, shape must be same. Size must not be, maybe or not be. That is why please note all congruent figures are shapes are similar, but similar figure must not be congruent. That is why all circles are similar, not congruent. All squares are similar, but not congruent. All rectangles are similar, but not congruent. Squares having the same side, equal sides are congruent and similar. That means congruent. If you are congruent, okay, fine, you are similar also. Circle of the same radius, 10 centimeters, then congruent, similar. There is no confusion. If you are congruent, you are similar also. But if you are similar, you are not congruent. Shape and size must be same. And another thing we can say, this is what here, everything is here. You can see that. What I told you, altitude, everything, it is not clear. Okay? Everything is here. I will show you. Now, in page number 79, we can see very important theorem BPT, that means tail theorem, basic proportionality theorem. What is that basic proportion? In page number 79, we can see Thales theorem, that means basic proportional theorem. What is the theorem? Look here, can you see a triangle? See my beautiful triangle is here. Blue, red, yellow. Look here, this triangle. The blue color pencil is here. If I am placing one more line, that means here somewhere here. Here. Okay. Here blue color is there. I cannot catch. See the triangle? Look. If a line is drawn parallel to one side of a triangle to intersect the other two sides in different points, the other two sides are divided in the same ratio. Now, let me catch here. Suppose I am catching here. One more. I need one more help, but nobody is here. All went to school. I also busy. See, I am keeping this blue pencil, two blue pencil parallel. This is parallel. If it is parallel only, yes, parallel. Parallel, okay. Then what is the telling? If this is parallel to this one, touching in two different points of other two sides, three sides are the distinct point, different point, then the ratio will be same. AO by OB is equal to AD by DC. Suppose ABC. The ratio will be same. This ratio I am talking about here is one ratio you are getting. It must be parallel. If it is parallel, then the ratio will be same. If a line is drawn parallel to the third side of a triangle, this is the third side. I drew here one line, blue, this is, then the ratio, the other two sides are divided in the same ratio. That means here the ratio will be same. Suppose this is 4. 4:3, it will be 8:6. Ratio same. That is it. BPT, basic proportional theorem. Now the converse, what we are telling. If the ratio are same, if the ratio are same, then the lines will be parallel. If the ratio are same, then the lines will be parallel to the third side. Okay, I will show you. Now listen, please. Let me share. Look. All of you, please listen here. What I told roughly, everything is here. You can see. Triangle. Similarity criterion of two triangles. That color you can see it. Two figures having the same shape and the necessary, not necessarily the same size, are called the similar figures. We are talking about two similar figures. Then all the congruent figures are similar, but the converse is not. Similar figure must not be. Two polygons of the same number of sides are similar. Their corresponding angles are equal and their corresponding sides are in the same ratio. That means proportion. Not it, same ratio. No need of equal. What it? If a line is drawn parallel to one side of a triangle to intersect the other two sides in different points, then the other two sides are divided in the same ratio. That is BPT. Fourth point is BPT. All of you know that BPT. I showed you BPT parallel to a third side. If a line is drawn parallel to one side of a triangle to intersect the other two sides, one side, a triangle has three sides, correct? Three sides. If a line is drawn parallel to one side, any side we can draw. Three sides parallel, any side. Now here parallel I can draw to this side. Look here. This side blue and yellow. Parallel, blue, yellow. Parallel I can see. If you draw parallel, it is not parallel. It must be parallel. It must be parallel. Okay. Then what we can say? Parallel to the third side. Then if a line is drawn parallel to the one side of a triangle to intersect the other two sides in different points, then the other two sides are divided in the same ratio. Okay. Now converse of that, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Converse. Okay. Now next one, all of you please. Same ratio, then parallel to the third side. Sixth one. If in two triangles, corresponding angles are equal, then their corresponding sides are in the same ratio as two triangles are similar. You can write this one, I told you, no need of that similarity. In two triangles, two angles of one triangle are respectively equal to the two angles of other triangle, then two triangles are similar. If two angles, in two triangles, two angles of one triangles are respectively equal to the two angles. If two angles are equal, for angle no proportional, that is equal, then the two triangles are similar. That is a similarity. SSS, that you know, same thing, congruency also SSS. But congruency, all sides are equal, but here proportional. If in two triangles, two angles of one triangle are respectively equal to two angles, that is over. AS similarity. In two triangles, corresponding sides are in the same ratio. Then their corresponding angles are equal. And hence the triangles are similar. What is that SSS criterion? In two triangle, if corresponding sides are proportionate, then their triangles are similar. Now, if one angle of a triangle is equal to one angle of another triangle and the side including these angles are in the same ratio, then the triangles are similar. SAS similarity. What is that? In two triangles, one angle of a triangle is equal to one angle of another triangle, and the sides included these angles are in the same ratio, then the triangles are similar. SAS. Are you following? Are you following or not? Okay, I think you understood. Sorry, the phone call came there. Now listen here. Centroid, point of intersection of three medians of a triangle. That is called centroid. Centroid divides each median in 2:1. Hello, listen here. I told you. Centroid. Then orthocenter. Point of intersection, three altitude of a triangle. A triangle has three altitude. Remember ortho T, altitude, ortho T, altitude. Don't confuse. Centroid, median, 2:1. Then circumcenter, point of intersection of the perpendicular bisector of sides of a triangle. Point of the perpendicular bisector of a side of a triangle. Circumcenter. For drawing a circle, circumcenter, incenter, next one. Point of intersection of three internal bisector of angle of a triangle. That is incenter. Don't confuse. Centroid, D is the point of intersection of the median. A triangle has three median. Next, ortho. I told you ortho, Malayalam, ortho, T is their altitude. Connect it, altitude. Point of intersection, the altitude of a triangle. Then circumcenter, point of intersection of three perpendicular bisector. Remember, circumcenter. And incenter, point of intersection of the bisector angle. That is incenter, inside. Angles, remember. Other thing, perpendicular bisector, orthocenter, circumcenter. What is that again? Centroid, orthocenter, centroid, median, orthocenter, altitude, then circumcenter, perpendicular bisector, incenter, angles. Angles inside, incenter, remember, the last is circumcenter, like that. Okay. Now, it is the role of you, please. A screenshot. I will send you this. Centroid, point of intersection, three medians of a triangle. Centroid divides each median 2:1. This is the centroid, my dear children. Centroid of a triangle. Can you see here? G. ABC is the triangle. Here C is the ABC. This is the C. Okay. ABC is the triangle. So, centroid. That means D is the median. There is no confusion. Half of AB. D is the middle point. So, we can see DC. DG is there. Then BF. A. Look, A, that is the median, middle point. Line from vertex to the middle point. A. Here we can see AG by GE. AG is to G is 2:1. If AG is 2 centimeter, G is 1 centimeter. 2:1. If AG is 4 centimeter, G is 2 centimeter. Everything like that. BG, G 2:1. BG, the long, from vertex to the centroid. I think it is clear. So yeah, same figure, centroid. Point of intersection of the median. Three medians are there for a triangle. Then coming to the orthocenter. Orthocenter, point of intersection of three altitude of a triangle. Three altitudes. Altitude, perpendicular. From vertex to the opposite side, perpendicular, 90 degree, can you see? This also from vertex to the opposite side, but it is not perpendicular, it is to the middle. You are looking middle, maybe perpendicular sometimes, isosceles triangle. But here it is perpendicular, altitude. altitude, ortho vector, T is the point of intersection of altitude, 3 altitude. Again, circumcenter of a circle. Listen here. Here what we can see? Here, circumcenter of a circle. That means point of intersection of the perpendicular bisector. We can see perpendicular bisector. 3 perpendicular bisector inside. That is circumcenter. We can draw a circle through the vertex outside the triangle. Now come incenter. If you are remembering incenter, circumcenter, no confusion. Incenter, point of intersection, the internal bisector, inside, internal bisector of the angles. So the circle will be inside. Don't confuse, this circle is not touching the vertices. This circle is touching the 3 sides. In center, the circle is inside. Radius is the distance. But here, circumcenter, we can say radius. What is the radius? We can see the radius. Radius is AD. That means one part of bisector A to the center, vertex. So it will be touching the triangle outside the triangle, in center. That is the triangle inside the circle. Okay, please note this one. Take screenshot of this one. Okay, I think you understood the concept. Any doubt, you can ask me. Next class, I will explain. Any doubt, you can send me. Okay.